Somewhere deep in the noise of the universe, a signal appeared that shouldn't exist. It wasn't random static, and it wasn't from any known source we've ever mapped. It repeated with a structure too precise to be natural, yet didn't match any human-made pattern either. Astronomers went back through the data, thinking it was a glitch, but it wasn't. The more they studied it, the stranger it became. Because this cosmic signal breaks the rules, and no one knows why it's there. Today we will talk about this cosmic signal shouldn't be there. So before we start, make sure to hit the like button and subscribe to my channel. 1. When the universe sends something it shouldn't. Astronomy is built on expectation. Every signal we detect from space, radio waves, X-rays, gamma bursts, fits into a framework shaped by decades of physics. Stars pulsate in predictable ways. Galaxies emit structured spectra, and even violent cosmic events like supernovae follow known energy distributions. So when researchers say this cosmic signal shouldn't be there, they are describing a moment where observation violently collides with theory. It usually begins in radio telescopes scanning the sky for routine data calibration. Suddenly, a spike appears, unusually narrow, unusually strong, and sometimes perfectly structured. The first reaction is always skepticism. Is it hardware failure? Atmospheric distortion? Satellite interference? Only after exhaustive filtering do scientists consider the unsettling possibility that the signal is real and coming from somewhere in deep space. 2. Echoes of history, the WOW signal, and beyond. One of the earliest and most famous examples of such an anomaly is the WOW signal, detected in 1977 by astronomer Jerry R. Eminwile, working on a SETI project. The signal lasted 72 seconds and was so striking that Emin circled it and wrote "WOW" in the margin of the data printout, giving it its enduring name. Despite decades of follow-up observations, it has never been repeated or explained. This moment became symbolic in astronomy, a signal strong enough to suggest intelligence, but too isolated to confirm anything. Since then, modern surveys have detected many strange emissions, including repeating bursts and one-off flashes. Among them, the class known as fast radio burst has become especially important. 3. Anatomy of an impossible signal. To understand why a signal is considered impossible, astronomers break it into measurable properties: duration, bandwidth, dispersion measure, repetition, and polarization. A normal astrophysical signal spreads across frequencies due to cosmic plasma, but some anomalous signals appear unnaturally clean, almost as if they were engineered. Others show repeating intervals with mathematical precision that natural chaotic systems rarely produce. For example, repeating FRBs like FRB 12110 challenged early assumptions that FRBs were one-off catastrophic events. Some signals even appear to shift frequency in structured patterns, raising questions about whether plasma lensing, magnetospheric activity, or unknown astrophysical mechanisms are at play. The phrase "shouldn't be there" often refers not to impossibility, but to incompatibility with existing models. In science, that gap between data and theory is where revolutions begin. 4. Noise, interference, and the Earth problem. Before declaring anything cosmic, scientists must eliminate Earth itself. Modern radio telescopes are incredibly sensitive, capable of detecting signals from billions of light years away, but that sensitivity comes with a problem. Earth is loud. Satellites, GPS systems, military radar, aircraft communication, and even household electronics create a dense fog of radio interference. A microwave oven in a nearby facility once famously mimicked a deep space signal in a research dataset. Because of this, observatories like CHIME in Canada and parks in Australia follow strict verification protocols. A real cosmic signal must be detected simultaneously by multiple independent instruments in different locations. If it appears in only one, it is dismissed. Yet even after filtering out human interference, a small number of signals remain unexplained. These are the ones that earn the label anomalous, not because they are confirmed extraterrestrial or exotic, but because they survive all known explanations. 5. Extreme astrophysics, when nature pushes limits. Many impossible signals eventually find explanations in extreme astrophysical objects. Magnetars, neutron stars with magnetic fields trillions of times stronger than Earth's, can produce enormous energy bursts capable of mimicking artificial signals. In 2020, astronomers even linked one FRB-like event within our galaxy to a magnetar, proving that at least some FRBs have natural origins. Black hole accretion disks, pulsar, glitches, and neutron star mergers also generate unpredictable radio emissions. However, even these extreme environments sometimes fail to fully explain observed patterns. Some signals show temporal stability or spectral purity that current plasma physics struggles to reproduce. This leads researchers to refine models continuously, adding layers of complexity to account for newly observed behavior. In astronomy, extreme is often just a temporary label for not yet understood. 6. The frontier of unknown physics. When all known astrophysical explanations fail, scientists face a deeper question. Could this signal point to unknown physics? This does not automatically imply intelligent origin, but rather incomplete scientific frameworks. Possibilities include interactions with dark matter, unknown, quantum effects in high-energy plasma, or exotic states of matter in neutron star crusts. Some theoretical models suggest that under extreme gravitational or magnetic conditions, space-time itself could produce emissions we have never observed before. Even anomalies in the cosmic microwave background have previously hinted at physics beyond the standard model. In this context, a strange signal becomes less of a mystery message and more of a clue, an indicator that our understanding of the universe still has gaps waiting to be filled. 7. The SETI question: are we hearing intelligence? Naturally, when a signal appears structured or unusually narrow, speculation about extraterrestrial intelligence arises. The search for extraterrestrial intelligence, SETI, has spent decades scanning the sky for artificial patterns. However, distinguishing natural from artificial signals is extremely difficult. A true technological signal would likely exhibit repetition, encoding, or modulation patterns that cannot be explained by chaotic astrophysical processes. So far, no confirmed signal has met these criteria. Even a famous WOW signal did not repeat, making verification impossible. Scientists remain cautious because the history of astronomy shows that nature often produces patterns that look artificial at first glance. Still, SETI continues its search because the stakes are enormous. Even a single confirmed artificial signal would fundamentally alter humanity's place in the universe. 8. Why these signals matter more than their answers. Ultimately, the importance of a cosmic signal that shouldn't be there is not whether it proves aliens or new physics, but how it forces science to evolve. Every major breakthrough in astronomy began with anomalies. Pulsars were once mistaken for possible extraterrestrial beacons. Quasars were once called quasi-stellar radio sources because they defied explanation. Fast radio bursts were unknown until just a few decades ago, and now they're a major field of research. Each unexplained signal pushes instruments to improve, theories to expand, and assumptions to be questioned. Whether the mystery is solved by magnetars, plasma effects, or something entirely new, the process itself drives scientific progress. In that sense, a signal that shouldn't be there is not an error in the universe. It is an invitation to understand it more deeply. But if you like this video and would like to see more like it, please give it the thumbs up, leave a comment, and click the button to subscribe.